All right, so y'all draw a big old squiggly line underneath that, and we're going to look at the next section. Guys, we're going to keep coming back to what we just looked at. We're going to keep adding some stuff to exponents as far as that goes, but we need to start looking at properties of exponents. And the first thing that we're going to look at is multiplication of powers. Okay, not talking about Matthew. We're talking about powers, which is a number raised, or a number that has an exponent with it, okay? Multiplication of powers. We are going to be multiplying powers together. Now, I'm going to write the general form on the board for you here. And it's not going to make sense to you. Y'all are going to be like, what in God's name is that? It's okay. We're going to write the general form. I'm going to show you how we write it in math, and then I'm going to show you how we would write it in English. I don't know how you'd write it in Chinese, but I'm going to show you how to write it in math, and I'm going to show you how to write it in English, okay? So the general form, just draw this little box right here, and it's going to make sense in just a second. We say a to the m times a to the n is equal to a to the m plus n. And guys, I know there's a whole bunch of letters up there, and I know it doesn't make a whole lot of sense, but do y'all know what the word arbitrary means? I'll take that as a no. Arbitrary means it doesn't really make a difference. Okay? It just kind of, it's, how do we say this? If I say the answer to number 4 is arbitrary, that means it doesn't really matter. If I say a to the m, if I said we're using letters right there because they're arbitrary, it means because they could be anything. Like, it works every single time. Like, A and M and N are all just, they could be any number. It doesn't matter. It works with every number. It could be 1. It could be 2. It could be 3. It could be 4. You know what I mean? Like, you could put any number in there and it would work. So that's why we use the letters right there. It's because it's just saying it's like the general form. It's going to work for any number. So we're just going to call it A. All right, now how we would write this in English. If the base is the same and you're multiplying, the rule is you add the exponents. Notice how I didn't say you just add the exponents. There's 2 stipulations here. The first one being is if the base is the same, and y'all know what the base is. What is the base of this exponent, or this power right here? What is the base for b right there? Yeah, it's -2. The base here is 2. All right? So if the base is the same, that's a big part of it. And you're multiplying. Notice how it doesn't say adding. It doesn't say subtract. If the base is the same, you're multiplying, you add the exponents together. If you have a, and we have an a right here, and we're multiplying, you just take these powers and you add them together. All right? So for example, example uno. Uno is Spanish for 1, okay? Y'all good? Okay. Example 1. If you have x to the 4th power and you multiply that by x to the 3rd power, you get x to the 7th power. You see how we got that? Guys, I'm not going to just throw up rules on the board and not tell you why it works. Like, that doesn't do anybody any good. There's going to be one time this year that I'm going to give you a formula, and I'm going to be like, hey, the reason why this works has to do with calculus, and y'all are not nearly there. So just take my word for it. There's going to be one time I do that. Every other time I'm going to show you exactly why it works. And here's why this works. Y'all put your pencil down, look at the board, put your pencil down, look at the board, put your pencil down, look at the board. If you have x to the fourth and you're multiplying it by x to the third, we have, how would you write x to the fourth as a repeated factor? How would you write that as an expanded form? X to the fourth.
X plus X plus X plus.
Not plus. X
Times
that, yeah. So you would have x times that. You'd have x 4 times, okay? So you say x times x times x times x, right? Okay, now we're multiplying that by x to the third. So we're going to multiply, and then how would you write x to the third in repeated form? Or
X times X
yeah.
times X.
X times x times x. Now if I wanted to rewrite this sentence right here, how many x's do you have right there?
7.
Yeah, and since you're multiplying all of it, you'd say x to the 7th. It's kind of like you're going backwards, okay? Here's what it is in repeated form, or as a repeated factor, and then how you would write this using exponents, you'd say x to the 7th. Y'all see how I got, like, y'all see the reason why it works? Now, if this said x to the 4th plus x to the 3rd, it wouldn't work, because you'd have a plus sign right there. You know what I mean? Like, it wouldn't work. All right, and I'll show you why that is in just a second if we had numbers, okay? But if the base is the same and you're multiplying, you can just add the exponents together. Write that down. You're gonna need that. Where's Jackson? Where's Alan? Alan and Jackson. That's a country singer. I don't like country at all, but his name is Alan Jackson. Alan Jackson. Alan, you see what we got there, my friend? Cool. Let's use some numbers now. All right. And guys, if ever I am moving too fast, if ever I'm kind of like, if you're not done copying something, I'm gonna say like, hey, y'all done with this? All right, cool. And I'm gonna go on to the next. Like, if I'm moving too fast for you, just say, hey, Portman, slow down. All right. Unless you're in La La Land. If you're in La La Land, I'm not gonna slow down for you. All right. Y'all good here? Okay. Example dos. That's two, Spanish for 2. If you have 2, all right, let's say 3 to the 7th times 3, that's a 7. 3 to the 8th. The directions here, and please listen to the words that are coming out of my mouth here. If it says write using exponents, if the directions say write using exponents or write in exponential form, that means you're going to write it using an exponent. What would your answer be to this question if it says write using exponents? I don't want to know what 3 to the 15th is. And sure as the day you were born, I'm going to get on y'all's quiz or test, if it says write using exponents, I'm going to have kids trying to multiply 3 15 times. I don't want to know what that is. That's a calculator question. I want you to understand the logic that's behind it. If I have 7 3s being multiplied by one another, and I multiply that by 8 3s being multiplied by one another, I have 15 3s that are all being multiplied by another. So your answer to this one would be 3 to the 15th power. I don't want to know what that is. I think on one of the quizzes I gave one time, it was something like 7 to the 9th power, and I had a dude that didn't finish because he was sitting there doing 7 times 7, 49, 49 times 7. Oh my God, 343, 343 times 7. I mean, he was going through and he did that 9 times. I wanted to go by and I thump him on the forehead. Dude, look at the directions. You know what I mean? It says write using exponents. I don't want to know what that is. All right, y'all understand the difference? Y'all good? Y'all understand why that works? Here's example 3. Same directions. Oh, I'm going to throw a little curveball at you here. That is an analogy for baseball. Okay? Curveball is something hard to hit, something y'all haven't seen before. 4 to the 11th times 4 squared times 4. Oh, boy. Jackson. What do you think your answer is for this one? If it says write using exponents.
I would say 4 to the 14th power.
Where are you getting 14 from?
Well, there's 2, there's 11, and that 4 is, I would say, 1 power.
What is the exponent for any number that does not have an exponent?
1.
There is an understood 1 right here. That is very important. Your answer here is not 4 to the 13th power, it's 4 to the 14th power. Because if I had 11 4s, and then I had 2 4s, and then I have another one, there's a total of 14 up there. Y'all understand the difference there? Like, that is a way that kids get tripped up, is they don't understand that there's an understood 1 right there for your exponent. So you got to add that one on there as well. You see the difference? You see, you got that, Stacy? You good?
Yeah.
Nice. Example 4. When you write that question down, put your pencils down, and then look up here. I want you just paying attention. You can copy it down when I'm done. I promise you I'll give you enough time, okay? Did y'all watch the World Cup at all
Yeah.
this summer? Did y'all watch it at all? A little
I
bit?
watched almost
I'll
every
watch
game.
one.
I'm still so upset about the Georgia losing the national championship game. I haven't watched a whole lot of sports since then. But I watched a little bit of the World Cup. There was a couple games. It was Argentina versus
Iceland.
no. It's the game that Argentina they lost. They got knocked out by somebody.
4-3 France, right?
I think it was France, yeah.
Yeah, 4-3 France.
Man, that was a good game. Alright. This one's a little bit different, right? Like, how is that one different from the ones we've seen before?
So that's the base is different.
Okay, I see what y'all are saying. This one is different. Like, what if I did not have the 5 and the 3 right there? If it said g to the 6 times g to the 7th, what would your answer be? G to the 13th, right? But we have a 5 and a 3 right there. I'm going to write the steps down just because we're running low on time. I'm going to write the steps down for it later. But what we're going to do first, guys, another way of reading 5g to the 6th would be 5 times g to the 6th. Because you know you have a number touching a variable, that means multiplication, right? So if I wanted to, I could rewrite this as 5, don't make fun of my 5s, 5 times g to the 6th times 3 times g to the 7th. You want to know how much math I've done so far? Nothing. I've just kind of spaced it out a little bit. All right? Now, moving forward. Is 2 times 3 times 4 the same thing as 4 times 3 times 2? And is that the same thing as 3 times 2 times 4? And is that the same thing as 4 times 2 times 3? Is all that the same thing? Would you get the same answer there?
Yes. Yes.
So you can rearrange multiplication any which way you want to, correct?
Yes.
Yeah. So I can rearrange this sentence right here since we're multiplying the entire thing. I can rearrange it any which way we want to. I'm going to put the integers next to the integers, or I'm going to put the numbers next to the numbers, the powers next to the power. What we actually call this is called a coefficient. I'm going to put the coefficients next to each other. That's a 5. 5 times 3 times g to the 6th times g to the 7th. Do you see how much I've done right here? Haven't done any math yet. I've just rearranged it so it's easier for us to look at. Would y'all know how to answer this question here? What's 5 times 3?
15.
Your little brothers and sisters can answer this question now. What's g to the 6th times g to the 7th?
G to the 13th power.
It looks hard. When you break it down, it's not that bad. And I understand, like, when y'all get to right there, y'all are like, that's my answer? Because it doesn't look like any answer that y'all have provided in math before. Y'all are used to getting answers that look like 4. You know, or the answer to number 6 is a square. Y'all are not used to seeing answers that look like 15g to the 13th. But if you don't know what the value of g is, you can't do anything more to it. Your steps would be to rearrange the sentence, put the integers next to the integers, the variables next to the variables, and then you multiply. Guys, I appreciate y'all listening. Y'all have a great day. If y'all have any questions, let me know. Subscribe to my YouTube channel. I need some more subs. I need some money in my bank account now, all right? I think I got about 100,000 more followers I need. All right, so tell your friends.
I'll tell my sisters.
Hey, if all 100 of my kids tell 100 of their friends, I'll be doing all right. I'll be making some money. Y'all be good. Do the next right thing. I believe in you.